courses at both UG and PG levels. Her area of specialization is wireless network, computer organization, and computer graphics. Ma'am has contributed to many international, national, reputed journals, and similarly in international level conferences also. Other than teaching, ma'am has done many academic related activities successfully. Very warm welcome to you, ma'am. The session is yours.
Cellular logic array processing of multi-dimensional using digital images. 5-day online webinar on artificial intelligence and its multidisciplinary dances. So I am a resource person, Dr.S.Geetha, Assistant Professor in Department of Computer Application, UCE, VIT Campus, Anna University, Tiruchirappalli. So what do you mean by cellular logic array processing? Means we have to combine Morgaux's normal algorithm at the same time von Neumann's cellular automaton we have to combine, and then we have to produce the cellular logic array processing, CLAP. So simply called as CLAP. So what do you mean by Morgaux's normal algorithm? Means, so this is the one of the algorithm. It is a substitutions algorithm. It is most important in this algorithm. So first of all, you have to take alphabet A and then two other symbols. One is substituted symbols, and another one is termination symbol. So arrow mark, right arrow, it is used for substitutions, and then dot means terminations. So we have to using the two formula. So P implies Q. This is one of the formula. Another formula is P implies dot. So we have to replace the Q from the alphabet A. So these two equations are called substitutions formula. First one is simple substitution formula. So as it is, B implies Q. Second one is termination substitution formula. Okay. So both P and Q are constant values. So you have to take any other values. So this is one of the algorithm steps, this one. So left and right part of the corresponding formula. So you can use hyphen. So you have to implies Q. So you have to, it is possible. So implies Q is possible. P implies. Otherwise third one is implies dot. So these are all blank parts of empty words. Okay. So the first type is called the injections formula. So that means the given substitution formula means we have to using two steps. One is the simple substitutions formula. Another one is terminations formula. So the application of substitution formula, it is mean by replacement of left part of the formula that occurs in the given word by right part of the formula. It is the most important. This one. So an added list of the simple and termination substitution formula is called scheme. So it is the most important word is scheme. So the scheme by the simple is yes. So we have to denote it as the simple is yes. So the ordered pair A comma yes. So A is any other constant. So alphabet. Yes means scheme. So both of it combined. So that is called normal algorithm, denoted by the symbol N. It is the simple algorithm for Morgaux's normal algorithm. So normal algorithm means we have to using the two symbol. One is the implied symbol, another one is dot. This one. So this is substitution formula. So both of you call substitution formula. First one is a simple substitution. Second one is a later terminal substitutions formula. This one. So the first type of the formula is called the insertion formula. Another one we have to using left part of the formula that occurs in the given word by right part of the formula. So that is called the scheme. So the given, it is consists of alphabet A and scheme S is known as normal algorithm. So that is denoted by the symbol N. So this is first example channel 1. This one is a channel 2. This one is channel 3. So first part is left part of the substitution formula. So the given N is found in P, then N is not applicable to P. So we have to denote it as negation symbol N of P. So in the given input is routed through channel 1. So the given input, the routed is channel number 1. So as it is the same formula, the simple formula we have to apply, then the resulting word from the substitution is again subject to N through channel 2. So you have to apply for the substitution formula. So next one is termination. So you have to terminate it. So after it, so you have to replace the another constant values. So the desired output due to N, it is routed through channel number 3. So we have to using channel 1 and then channel 2 and then channel 3. So first one, none of the left part of the substitution formula of N is found in P. So N is not applicable to P. So this type of method, so we have to route it through channel number 1. Next one, we have to apply the given substitution formula. We have to using the channel number 2. Next, we have to apply the termination formula. So we have to apply for the channel number 3. So how will you apply in the normal algorithm for right adjusting a word to a given word? So this is a simple example. So how will you execute it in the normal algorithm? So first of all, I am using only one algorithm. I am using, it is called substitution formula. So alpha mu. So you have to any other constant value. So mu means any other constant value implies mu alpha. So alpha is terminated. So you have to replace it by Q. After that, the given alpha. So first of all, we have to take the two word. One word is 0, 1, 0. So you have to take any other word. So it's 0, 1, 1. So or 1, 0, 1. So whatever it is, you have to using the word Q. So I am using only Q value equal to 0, 1, 0 and word P equal to 0, 1, 0, 1. So how will you execute in the substitution formula means, so this one is a 0, first step 0, 1, 0, 1. So this is the input string. So it is substitution by alpha 0, 1, 0, 1. So what is use of the substitution formula? Alpha mu, it is implies mu alpha. So first of all, alpha and then 0. So how will you substitute it? Alpha 0 means we have to apply the substitution formula 0 alpha. Okay, alpha mu is in this first step. 0th step, alpha mu equal to mu alpha. So first of all, we have to take an alpha. This one is 0 is the mu. So replace, we have to apply the substitution formula. Alpha mu is changed to mu alpha. So remaining input values as it is the same. Next one, alpha 1 is substituted 1 alpha. Next one, alpha 0 is replaced at 0 alpha. So next one, alpha 1 is 1 alpha. Okay. So at the end, so this is the termination. So alpha is terminated. So now you have to apply Q values. So you have to terminate it. So you have to replace it by Q word. So what is the Q word? 0, 1, 0. So 0, 1, 0, 1. So in this replaced by 0, 1, 0. Is it clear, ma? Is it clear now? So how will you apply in the normal algorithm in? Hello? Hello? Hello?
Yes, ma'am, you're audible, ma'am.
Yes. Is it clear, ma'am? Is it clear? Normal algorithm for right adjusting?
Yes.
Yes. Okay. It is a simple example. So you have to any other word. 8-bit word or 16-bit word. So you have to take any other word. P. So it is the input string and then Q is another word. So if it is terminated, you have to replace the word Q. This end. Next one, cellular automata. So what do you mean by cellular automata means? So it is one of the parallel processing, more than one process or executed or updated simultaneously. So it is called the cellular automata. The same processing we are using in the cellular automata. So who is inverted means Stain's law, Ulam and von Neumann. So both of you invented cellular automata. So the term cellular automaton, what do you mean by cellular automaton? Means denotes regular uniform lattice. So infinite in extent. So it is a definition for cellular automata. So discrete variable at each site. So in the state of cellular automaton at the time incident. So at the time the given formula is executed. It is determined by corresponding configurations. So the array of values of these variables at that time incident. So three type of cellular automata, one dimensional and then two dimensional cellular automata and then three dimensional cellular automata. So it is based on only at the time incident. So one dimensional cellular automata, how will you work? Means at this state, at the time of t, psi of t at the time of t, psi of at the time of t I minus 1, psi of t I and psi of t I plus 1. So we have to using the three neighborhood of I. So if you want change, we have to apply the updating rule. So this is updating rules. If you want to change the particular bit values, so you have to change the I minus 1 at the same time I minus I plus 1. So apply to the configuration at the stage t. So at the same time you have to execute it, the three values. So the value of the ith cell, psi of t is updated as psi of t plus 1 and where psi of t plus 1 of I, psi of t I minus 1, comma, psi of t I, psi of t I plus 1. All cell values in the configuration are updated simultaneously. It is the main important points. All cell values in the configurations are updated simultaneously. Now we are using the three neighborhood values. So consider the modulo 2 rule, psi, where psi equal to t plus 1 of at the time of t plus 1 of I equal to psi of t I minus 1 exclusive or psi of t I plus 1. So now you have to apply for the updating rule. So you have to use any other updating rules. So now we are using exclusive or. According to this rule, the value of the particular cell is simply the sum of modulo 2 of the value of its two neighbor cells on the previous time step. It is the most important in this evaluations. So now we are using the two-dimensional cellular automata. So this, you have to apply 5 neighborhood rule. After that, 9 neighborhood rules. So you have to any other rule you have to apply. So first of all, we have to taken for the first rule, 5 neighborhood rule. So first of all, we have to change I comma j. So you have to change the values I comma j at the time of t plus 1. You have to change the time of t plus 1. Now you have to change I comma j minus 1, I minus 1 comma j, I plus 1 comma j. After that, I comma j plus 1. So at the same time, the 5 rules, the 5 values are changed at the time of t plus 1. Okay, so this is the 5 neighborhood rule. Another one is, so you have to apply for the 9 neighborhood rule at the time of psi t plus 1. So next t plus 1 of I comma j. So if you want to change the I comma j value, so next t plus 1 now at the time of t plus 1. So we have to change I comma j minus 1, I comma j plus 1, I minus 1 comma j minus 1, I minus 1 comma j, I minus 1 comma j plus 1, I plus 1 comma j minus 1, I plus 1 comma j, I plus 1 comma I plus 1. So at the time of t plus 1, we have to same time. So the 9 formula is applied at the same time. Simultaneously they are applied. So it is most important in the two-dimensional cellular automata. So it is changed. So how will you in the pattern 2D, 5 neighborhood cellular automator. So how will you change me? So in this pattern, the given values automatically change. Okay, so the color will be changed. So pattern generated by 2D 9 neighborhood cellular automated. So the given value 9 value each and every cell. So you have to apply each and every cell. You have to change at the same times. So this is the yellow color, next one red color, gray color, brown color. So this color, so this is dark red, light red color, so brown. So the given pattern is generated. So next you have to apply 3-dimensional cellular automata. So 1, 2, 3. Okay. So so 3-dimensional cellular automata means we have to apply the 7 neighborhood structure. This one 9 neighborhood structure. So at the time of psi t plus 1, at the time of t plus 1, you have to change. First of all, you have to change I, J, and then so sorry ma. So I, J, and then k minus 1. So next these 9 values I, J, k, I, J minus 1, k, I plus 1, J, k, I minus 1, J, k. So next only one cell is changed, I, J, and then J, k plus 1. So so 7 neighborhood structure we have to change. So the given generated for the another pattern. So at the same time 9 neighborhood structure is IJK. So the central cell is executed. So previous cell I minus 1, J minus 1, K minus 1, I plus 1, J minus 1, K minus 1, I plus 1, J plus 1, K minus 1, K plus 1, I minus 1, J plus 1, and then K minus 1. So this one, I minus 1, J minus 1, K plus 1. So the 9 values are changed at the time of T plus 1. It is the most important. If you want, you have to apply any other neighborhood. So if you want, you need 7 neighborhood structures, or you can apply 9 neighborhood structures. So whatever it is, you have to using in the 3-dimensional cellular automata. So that based on these structures, the given values or given colors automatically changed. So what not using the colors, the given pattern is changed. Okay. So this is pattern. So first of all, the central value is 5. It is a given input. So first evaluation and then second evaluation. The pattern generated by 3D cellular automata from seed value 5. Automatically changed. So in this value. So now you have to apply it for the previous pattern. So you have to any other pattern, you have to apply 7 neighborhood pattern, or you have to apply it for the 9 neighborhood structures. So after that, the given pattern is generated. Next, you have to apply it for the major important role is cellular logic image processing. So what do you mean by in this role? So if you want the given image is processed form in initial configuration from which a cellular automaton evolves and produce a desired processed image final configurations using updating rules. So whatever it is, you have to apply. Already we are studying 3 neighborhood, 5 neighborhood, and 7 neighborhood, and then 9 neighborhood. Whatever it is, you have to apply to any one of the neighborhood values. So first of all, you have to set the given images. After that, the cellular automaton produce and the desired processed image give the final configuration. So for final images using the updating role. So it is a major important meaning for the cellular logic image processing. So every image processing algorithm is defined by updating rule. Whatever each and every image processing algorithm is defined by updating rule. So updating rule is the normal algorithm. It is most important. Updating rule is the normal algorithm. It is consists of ordered sequence of substituting formula. It is most important. So you have to apply for the updating rule is the normal algorithm. It consists of order of sequence of substitution formula. So the traditional image processing algorithm likes segmentation, binarizations and edge detections and morphological operations are also proceed using cellular automated rules. So it is normal image processing. But we are applying in the cellular automata rules. So what do you mean by two-dimensional digital images? Morphological operations. Morphological operation 2D dimensional images. First one, cellular logic algorithm for dilation. So this is algorithm. It is most important. So you have to using the structuring element. You have to apply for the 9 neighborhood method. So this is the formula. This is algorithm step. Add pixel of structuring element to the corresponding pixel of the image. Find the maximum value k among all of them if at least one of the image pixel that is spanned by the structure element is non-zero. Then replace the central pixel in the image with k. Otherwise, it is replaced it with 0. So using this algorithm, we have to, the given images is dilated. So until structuring element spans the whole images. So what do you mean by, so you have to apply this. So this is one of the structuring element. This is the original element. Now we are using this algorithm. So dilated images is, the given output is dilated images. So next one, the same algorithm, cellular logic algorithm for erosion. So it is also one of the algorithm step. So dilations means you have to apply the add the pixel. Erosions means you have to subtract the pixel. So now as it is the same structuring element from the corresponding pixel of the image, find minimum k. Adding means maximum k, subtraction means minimum k. Among all of them, if all the structure element pixel are less than the corresponding image pixel, then replace the central pixel in the image with k. Otherwise, replace it with 0 until the structuring element spans the whole images. So this is the original images. Now we are using the structure element. After that, erosion images. So next one, cellular logic algorithm for segmentations. So the particular segmentation is how will you applied. So digital image of the size n by n. It is scanned by 3 by 3 window. So 3 by 3 sub-image covered by the window is examined whether the central pixel values lie. So this is the central pixel values lies in between specified gray region, including its lower and upper threshold values. If it is found to lie in that region, then the central cell is assigned a particular gray value. If not, the particular values is not applicable, means it is assigned the value 0. This procedure is continued till the entire image is scanned. So the overall effect is that entire gray level images is transformed into image having only 2 values. So this is the original images. It is the boundary. So only these 3 by 3, only the 3 images will be changed to gray color. So segmented images. So now we are applying the same processing. It is very important one. So you have to apply. So it is the whole image n by n. Now only you have to cover by 3 by 3 image. So now you have to the given image 3 by 3 images only converted into gray. So next one, cellular logic algorithm for binarizations. So binarizations means only you have to apply for the 2 values. One is 0, another one is 1. So now we are applying, now we are using 3 by 3 empty window over the images. Check whether the central pixel values lies in between specified lower and upper threshold values. If it is found to lie in that region, then the central cell is assigned to particular gray value. If not, it assigned the value 0. So the structure element spans the whole images. So this is the original images. This is segmented images. So segmented. This is a binary station. We ought to apply the algorithm for binary station. Binary station means only you ought to apply for the 2 values only. So next one, cellular logic algorithm for edge detections. So now we are applying for 5 segment structures over the image exam. So it is one of the algorithm. So how will you execute it in this algorithm? Means examine all pixel of non-zero 5 neighborhood, find maximum red value or max, minimum red value or min. So what is the difference between two values? DR. The same values you have to apply for the green max and then green min. So the difference between the two values DG. Next we got to apply the blue values, blue max and blue min. So the difference value is dB. If all the values dr, dg and dB are less than or equal to the threshold value t, then replace the central pixel value is 0, else slide the 5 neighborhood structures until structuring elements span the whole of the images. Only outline. So this one, the flower, edge detected. So this one is edge detected, edge only display. So this is edge detected images. Next one, cellular logic algorithm for thinning and skeletonizations. So now we are applying the 2D digital images. So the given formula is 5 neighborhood structure over the images. It is also another main example. All the pixel of non-zero 5 neighborhood, find maximum gray value G max, minimum gray value G min. So find the difference between two values D. D is less than or equal to threshold value T. Retain the central pixel value and remove the boundary cell. Else slide 5 neighborhood structures. So structuring elements span the whole of the images. Repeat this procedure till there is no boundary left for removal. So the resulting final image is the thinned version of original images. The corner pixels are also retained along the central pixel. Then the result final image is skeletonized versions. So this one is the thinning process. This one is skeletonization process. So this one, it is the example. So this is sample pattern. So thinned pattern. After that, skeletonization pattern. So next one, morphological operation on 3D. So how will you apply for the 3D dimensional digital images? So morphological operations used in the image processing, we have to using only two. One is 3D dilations and the another one is 3D erosion. So the operations are carried out on a given image by means of another image called 3D structuring element. Already we know the structuring elements. So you have to apply any other rule, 7 neighborhood rule or 9 neighborhood rule or 5 neighborhood rule or 1 dimensional means 3 neighborhood rule. So you have to apply any structure element which is 3D digital images used to operate on a given 3D digital images. So now you are using 27 neighborhood or 19 neighborhood and 7 neighborhood 3D structuring element are shown below. So this is one of the 9 neighborhood. So this part is 9 neighborhood. This one is 9 neighborhood. So totally 27 neighborhood formula is applied at the same time. It is most important, this one. Otherwise, you are applying for the 19 neighborhood algorithm. So first one is 5 neighborhood. This one is 5 neighborhood. This one is the second one is 9 neighborhood. Next one 5 neighborhood. So totally 19. So at the same time, the 19 formula are applied in this method. Next one, 7 neighborhood one means first one 5 neighborhood, another one is 1, another one is 1. So this is I means this one is I minus 1, this one is I plus 1. So 3D structuring elements are given below. So this is the structure, main structures. You have to apply any other formula. You need 27 neighborhood formula. Otherwise, you are applying 19 neighborhood formula. Otherwise, you have to apply it for the 7 neighborhood formula. So already we know this. What do you mean by 7 neighborhood or 9 neighborhood formula? Already we know that. So this one is morphological operation on 3D dimensional digital images. Cellular logic algorithm for 3D dilation. So it is the major algorithm step. So heavily executed. Now we are using only 7 neighborhood algorithm. This method. So we are not using the 19 neighborhood or 27 neighborhood. Now only using for 7 neighborhood algorithm only used in the 3D method. So whatever it is you have to apply. So if it is needed, 19 neighborhood algorithm means you have to apply this method. So 19 formula you have to apply in this system. So automatically 17 formula is executed at the same time. It is the most important, this one. So 3D structuring element over the 3D images. So it is one of the most important formula for the 3D. Add voxel of 3D structuring element to the corresponding voxel of a 3D image. Find the maximum K among all of them if at least one of the 3D image vowels that are spanned by 3D structure element is non-zero. Then replace the central vowels in the 3D image with K. Else or otherwise replace it with 0 until 3D structuring element spans the whole image of 3D image. Okay, so it is you are using it is a medical data, MRI images. So now we are applying 7 neighborhood method. So after that, dilated images and the selection from 40th. So executed 40th slice with the 100th slice. 40th layer the 100th slice where we have to execute it. After that, the given result it will be displayed on your screen. So it is very clear data. So erection method, repeat sliding 3D structuring element over the 3D image. So first one is dilation means add vowels. So erections means already we know that erections means subtract vowels. 3D structuring element from the corresponding vowels of 3D image. So find the minimum K. So among all of them, if all the 3D structuring element vowels are less than or the corresponding 3D images vowels, then replace the central vowels in 3D image with K. So it is a major important algorithm step in erosion. So first of all, you have to subtract vowels of 3D structuring element from the corresponding vowels of 3D image. It is most important. So find the minimum K among all of them if all the 3D structure element vowels are less than the corresponding 3D image vowels, then replace the central vowel in 3D image with K. Otherwise or else replace it with 0. So this one is eroded image values. This is also 40th slice and 100th slice. Next important one, edge detection. Cellular logic algorithm for 3D edge detection. So now we have to apply for the 7 neighborhood structuring element. So 7 neighborhood structuring element over the image. Test vowels of non-zero 7 neighborhood. Find out red color maximum value and label it red max. Find out red color value and label it red minimum. So this one is the maximum value, means you denoted as red max. Minimum value means we denoted as red min. So what is the difference between D red? At the same time, we have to apply green max means green max. Minimum means green color. Minimum value is green min. The difference and difference the label is D green. So next you have to apply the blue. Find out the blue color maximum value, and then so the given label denoted as blue max. Blue color minimum means the given label denoted as blue min. So the difference between two values, difference blue. When all the values, difference of red, difference of green, and the difference of blue are less than or equal to user defined threshold value T, then assign 0 value to RGP. So component of all these 7 vowels, else the slide the 7 neighborhood until the structure element scan the whole of the 3D images. So this is one is whole of the 3D images. Next one, cellular logic algorithm for 3D skeletonization. Repeat sliding 7 neighborhood structuring element over the image. Test vowels of non-zero 7 neighborhood. So find out red color maximum value. The given label it as red max. Find out red color minimum value. Label it as red min. So the difference between maximum and minimum of red values, and the label it as red D red. Find out a green color maximum value and label it as green max. Green color minimum value and its label it as a green min. So the difference between maximum and minimum value, the label it as a green min. At the same blue color max means a blue max. Blue color minimum means a blue min. So the difference the blue color D blue. When all the values D red, D green and D blue are less than or equal to a user defined threshold value T, then retain RGB component of central vowel value of forcing corner vowel value to 0, otherwise or else slide the 7 neighborhood until the structure element period whole of the image. Repeat this till no boundary is detected. So this one, the boundary does not change, only you have to apply in this formula. So we have to change the boundary values, skeletonization. So now I am using this software, Logical Image Processing System version 3.0. So this software I am using in this software. Next, Logical Image Processing System version 4. This is advanced in this software. So this is original image, gamma corrected. Now we are applying any other images you have to convert it. So in this software, very powerful software. So it is automatically changes the gamma. How will you change the gamma corrected images, high pass filter images? So whatever it is, given original images automatically changed in this method. So now you are using the Logical Image Processing version 4.0. So this is a software, Logical Image Processing version 3.3. So how will you, the simple method 3.0, collection of number of logical image processing tools developed using Visual C++, Windows 2000 XP environment. The algorithm pertained to most of the routine in these packages have been developed is a novel logico-mathematical framework called cellular logic array processing. Non-digital parallelism and begins pattern directed search and replace technique. So guarantee speed and precision. So it is the in this software. It is most powerful software and also very powerful in version 4.0. This is what are the packages or what are the commands we are using in this develop the software. So the conclusions. So the conclusion of the topic is depth study of Markov normal algorithms and the whole Newman cellular automation lead to formation of cellular logic image processing. It is most important. So first of all, you have to using Markov. What do you mean by heavily executed in normal algorithm and also Newman's cellular automation, Won's Newman cellular automation. So how will you apply it in this cellular logic logic image processing? So the number of cellular logic algorithms have developed at the part of this research. Some of which are provided in this report. So most of the persons are using CLAB. CLAB means cellular logic image processing. So complete the research. Most of the researchers are using in this software has not been reflected in this report due to the time and then space constraints. Working with the software engineers in the development of logical image processing system. Personally, I feel that this software immense and for use for the researchers and other students. It is most important in this software. It is very powerful software, this one. If it is any doubt.